Okay. What about the students? Okay. Okay. Welcome, guys. Welcome to class. And my name is Mr. Dami. And in this class, we shall move on from where we stopped the other class. You know, we've been working on mechanics. So all of what we've been doing so far has been mechanics. We've been taking different topics under mechanics. And that's been a very just please, you can mute as you come in. You can get yourself muted so that there'll be no noise. Now, I said all we've been doing so far has been mechanics, and we've checked in last class. We work on fundamentals, scalar and vector, motion, and I promise you guys that when I'm coming again in next class, I'm going to have something to write with so that we can practice more. And also, I don't know if most of you, if you're all in the classroom, there's a classroom for this project, and we want you to join the classroom so that you can communicate more effectively with me in case you have questions and in case you want to practice. Like in the last class, I sent work to be done to the classroom, like practice quiz, and I noticed that nobody did it. Like students didn't check it out. It was not done by anybody, and that
Good
was
morning,
not
Mr.
so much.
Damilola.
Solomon,
Yeah, I don't have access to the,
to the what?
I said I don't have access to the classroom.
To the classroom.
Yes, I don't have access to the classroom.
Okay.
How do we get
Solomon,
there?
you on WhatsApp.
Yes, I am.
Okay,
Yes.
okay. The access to the classroom will be sent to you. You can just drop your mail in the
Okay.
on the WhatsApp page. Drop your mail on the WhatsApp page. They will send you access.
Ah, there's no WhatsApp page now.
No,
I didn't see any WhatsApp page.
there is a WhatsApp page for us, for you, and for other students. I think there's a little bit of communication issues here. And I don't know if Bridget can help us out. Aaron, can you help us out? Or Bridget, can you help me out here? Yes, we can hear you. I can hear you.
Yeah, I can hear you.
Okay. 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 That was very good. Okay. Okay. So Solomon, I hope to see what you will score in the quiz. Just practice. Most of those questions are standard questions. So practice with them. And today's class is going to be more better than the last class because we are going to be going to higher topics like movement and so on. So, but we will still just browse through what we did last class and we will move higher. So, for the fundamental quantities, I said that there are 7 fundamental quantities and we listed them. And we have also derived quantity. But the most, I discovered that over the years, Jamb stress more on dimension. That means if they are going to ask you questions on fundamentals, they will want to ask you questions. Most importantly, they might want to ask you questions on dimension because over the years they do ask questions on dimension. So I observe that you should really work hard in getting yourself used to your dimensions. Okay, so on fundamentals, I would like to give you a question. I gave you an explanation last class, which I will not want to go over. Just go through the video and you'll be fine. But for the sake of emphasis, just to strengthen you on some things, I'll just give you a quick question. Let's check this out. I'm going to present to you my writing position. This is where I'm going to be writing. I'm going to write in from the Jamboard. I hope you can all see this. Now, if you were asked to give the dimension of power, hello, can you all see this? Dimension of power. Hello. I hope you
Yes,
can
we
all
can
see.
see it. We can see it.
Okay. Okay. The first thing to think about is what is the formula of power. which is what? Force times distance. That's work per time, or energy expended per time, or work per time. So this is, and work itself is what? Force times distance over time, right? While force itself is mass times what? Acceleration times distance over time. These two are from force. Okay. Now, mass, the unit of mass, I'm coming from formula to unit. This is the formula. I'm coming from formula to unit. The unit of mass is kilogram. Acceleration is meter per second square. And distance is meter, and time is seconds. That will give me kilogram. Meter times meter is meter square. Seconds is become seconds raised to power minus 3. Is the unit. It is from the unit that you will get the dimension. Dimension will now be which quantity is the owner of each of these units. Kilogram belongs to mass. Meter belongs to length squared. Second belongs to time. Okay, raised to power minus 3. This is the dimension of power. Now, you may be asked any other question. You can even be asked to give the dimension of density. So take note of this. Density is mass over volume. The unit of mass is kilogram. Volume is meter cube. That will give me kilogram per meter cube. This is the unit. I came from formula to unit. Then from unit, you will now come to dimension. This is the dimension. This is the dimension. Dimension will now become, when you get the which quantities are the owners of this unit. Kilogram belongs to mass, meter belongs to length. This is the dimension of density. So this is how we form dimension. And I stress this because I noticed that Jamb always has something to do with dimension. Please, is this clear? Now, if you go to the quiz, you will see questions on this. But I want us to get to this class. I think I stopped last class on something that has power, work, energy, and power. So I'll take it up from that position in this class. So I'm going to present to you the slide again. Okay, so let's move on. We've been here last time on dimension, on length. You have this document in your classroom, so you can still go over it. And on friction, you know that I spoke about vertical components and horizontal components. The horizontal is always cos theta. So vertical is always sine theta. So I discussed that in the last class. We have been all through this place. We've gone through this ones. I spoke about vector quantities and scalar. I came to motion. I spoke about bullet formula. MV, that's momentum of gun. That's the recoil of the gun equals the momentum of the bullet. Through this place, we went through centripetal force. We came to motion and we stopped here. I think we stopped. Okay, we came here. Did we get it? I think we stopped somewhere here. Okay, we stopped somewhere here. Okay, but if I have time, I will come back to this one to explain this one. Or let me just take it up from here. Let's take it up from here. A lead bullet of mass 0.05 kilogram is fired with a velocity of 200 meters per second into a lead block of mass 0.95 kilogram. Okay, this is the real question. Given that the lead block can move freely, the final kinetic energy after impact is what? Now, this question gave you mass and velocity, and it's asking for kinetic energy. Now, when you hear that something like a bullet is fired into an question that has mass and velocity, that kind of question, in most cases, always have to do with what we call collision. This question is a collision question. Now, but it is not just asking for just anything. It is asking you beyond collision to use that collision value to get kinetic energy. Now, when you are dealing with collision in motion, guys, can you all mute yourself, please? I am easily distracted. If you have a question, unmute. I will believe that you have a question. Can you all mute yourself? Hello, can you all see my screen?
Yes.
Okay, perfect. Please, if you have any question, you have the right to stop me and ask me, please. A lead bullet of mass 0.05 kilograms is fired with a velocity of 200 meter per second into a lead block of mass. Now you are seeing mass and mass. Something move and enter another mass with a speed. Given that the lead block can move freely, find the final kinetic energy after impact. Now, what are you supposed to do? I said before that this question is a collision question. It's like something eating something. Now, under this question, under motion, you have been taught about collision. And we know that there are two major types of what? Collision, elastic and inelastic collision. Okay? It is always between kinetic energy and momentum. Okay? Elastic collision is where two of them are what? Given. But in inelastic, one of them is conserved. Okay? And that is the what? Is the momentum is conserved. Now, in this case now, we have collision between going from the gun into the lead body. Okay. Now, whenever you are dealing with this kind of question, you must use a formula that has to look like this: mv1 plus m2 v2 equals v bracket m1 plus m2. Generally, I want to take you to the board. I want to show you something broader. This is not all. In case you are given a question that is not in that format, give me a minute. Okay. Okay, I think, oh, I'm a little bit stuck on this. Okay, if this comes up, I think it's for my internet. I can't switch slide. Okay, let's go on. So we said that because there are two major type of formulas you might be tempted to use. But any question on mass and velocity should make you think of collision. Now, you are given masses, two masses and one velocity. To find this, your first job is to find the second velocity or the final velocity. So the formula to use in most of this kind of question is m1 v1 plus m2 v2 equals m1 v1 plus m2 v2. But in this case, since the body that was being shot is not moving, it will not be double V. It will not be equals M1 V1 plus M2 V2. It will become single V because the body that was being shot is not moving. Bracket M1 plus M2. So this is before the person shot. There are two bodies. One for the gun, mass 1, V1 for the what? For the gun, because the gun was actually moving. Then M2 is for the bullet, and V2 is meant to be for the bullet, but I didn't put V2 here, I put 0. Why? Why is it so? Because what is being shot is not moving. So bullet was moving from this gunsman into a stagnant body. Okay, now let me say it this way. The bullet has its own M and its own V. That was the M1 V1. This lead body, this block being M and V. But why is its own V is 0? Why? Because the block is not moving. So velocity of the block to use. Now, but after it was shot,